Okay, we want to begin now, section 3.4. We're going to continue talking about polynomial functions and zeros and factors. But what we're going to do in this section, and you don't have very many problems on this, but it's very important that you pay attention and take good notes on this, is what you're going to be doing in this section is you're going to be graphing a polynomial function. And so we're going to carry this one step further because we haven't graphed any of these polynomial functions. All right, what I want to do first is I want to give you some just general background information. Some of this stuff you'll need to write down. I will tell you what to write down when that time comes. But anyway, let me just throw out just some general things first. First of all, in order to graph a polynomial function, one thing that is very helpful is when we know the zeros. And the reason is remember the zeros is where the graph crosses the x-axis. So that's important. So when we go to graph these polynomial functions in a few minutes, the first thing I'll do is find the zeros. Well, what if I don't have the zeros? Then we're going to have to make our list, like we did in the last video. Make our list, find all of the zeros, and then we'll graph it. So we'll talk about that in just a few minutes. But before we get to that, I want to talk about something else, and it's this. It turns out that when you're watching when you're looking at a polynomial function, when you graph any polynomial function, they look sort of like this. In other words, a polynomial function, the bigger the degree, and remember what was the degree? The degree was the biggest power on x. Like if you had an x to the third, that's a third degree polynomial. Or if you had three linear factors, x, and x, that's x to the third. The bigger the polynomial, the bigger the degree, sometimes the more complicated that graph can get. But what a polynomial function does when you graph it is when you're drawing that graph, that thing will bump or what I call oscillate a couple of times, but it doesn't oscillate forever. For instance, in this problem right here, this graph right here oscillated 2 times or bumped 2 times. This graph right here oscillated 1, 2, 3 times. This graph right here oscillated 1, 2, 3, 4 times. But after a while, that polynomial function, it don't oscillate forever. Now, there are some graphs in mathematics that oscillate forever. Those are called sinusoidal functions. These do not. Polynomial function doesn't. So after a while, the very ends of the graph, what we call the far left and the far right behavior of the graph, after a while, that thing will quit oscillating and it will just... It'll just either turn and go down forever or turn and go up forever. For instance, in this problem right here, the far left behavior is down, so it never oscillates again. The far right behavior is up. In this one, the far left behavior is up. The far right behavior is up. In this one, the far left behavior is up. The far right behavior is down. And this one right here, the far left behavior is down and the far right behavior is down. So either they do this or this. They either both go up or they both go down, or one goes up, one goes down, or vice versa. Those are the 4 options. Well, here's what I'm about to do. I'm about to show you how to look at the polynomial function without even touching it. And I'm going to show you how to tell what the arms do, whether they go up or down. I want to show you how to do that. Before I show you, let me just tell you this first. If it's an even degree polynomial, that means an x2, an x4, an x6, an x8. If the biggest power of x is an even number, both arms go the same direction. They either both go up or they both go down, if it's an even degree. Now, if it's an odd degree polynomial, one arm will go up, one arm will go down. So this problem this one right here is an odd degree polynomial. This one right here is an even degree polynomial. This one right here is an odd degree polynomial. This one right here is an even degree polynomial. Now, what determines which way they go? Do you remember that leading coefficient we were talking about in the last section, that L, the leading coefficient? Well, if it's positive or negative, that affects your arms on a graph. I'll say it and then we'll write it. If it's an even degree polynomial, that means both arms go up or both arms go down. If the leading coefficient is positive, they're going to both go up. But if it's an even degree polynomial and it's a negative leading coefficient, they're going to both go down. Now, if it's an odd degree polynomial and the leading coefficient is positive, the left arm will be down and the right arm will be up, But if it's an odd degree polynomial with a negative leading coefficient, it swaps it around. The left arm is up and then the right arm is down. Let me show you what I mean. So, if we have an even degree polynomial with a positive leading coefficient, both arms will go up. Let me give you an example. Let me get this right here. Pause the video if you need to. Okay, first of all, if I ask you what degree polynomial is this, remember the degree is if you was to multiply it all back out, which I'm not going to do. But if I multiply this out, x times a x times a x times a x would be a x to what? The fourth. So this is an even degree polynomial. So that means if I graph this, either both arms will go up or both arms will go down. Now, what determines that? Well, that first number, is it positive or negative? Well, you have a 1x times a 2x times a 1x times a 2x. All those are positive, so that would be a positive even degree, which means both arms will go up. Now, that thing may oscillate multiple times, but both arms will eventually go up. Okay, now, if it's an even degree but a negative leading coefficient, for instance, this one right here, even degree, negative leading coefficient, in this case, both arms will go down. So, it may look something like, I don't know exactly what it looks like, but it'll have that shape. Both of these arms will go down. Now, let me give you an example of the odd degree. If it's an odd degree polynomial and a positive leading number, let me give you a visual. That's right here. You say, well, how do you know this is an odd degree? What's a x times a x times a x? X to the third. So this is a third degree polynomial. A third degree polynomial, and then 1 times 2 is positive. So the front number's positive. So it's an odd degree, positive number out front. So I said in this case, and this is where you have to remember it, in this case, the left arm goes down and the right arm goes up. So just to give you a picture of what this would look like, maybe something like that. Now, let me show you how this is helpful in drawing a graph. Look at this problem right here because I've given you you're looking at the three linear factors right there. What are the three zeros to this problem? -3, -1, +5/2. -3, -1, +5/2. You don't have to graph this. If I plot these three zeros right here, and again, you don't have to graph this, just watch. Ignore the graph right now. So -3 is here, -1, 2, 3. -1 is there. And 5/2 is 2.5. 1, 2.5. So here are those three zeros. Now, what do we know about the very left end of the graph? It goes down. What do we know about the very right end of the graph? It goes up. So what do you think it has to do from here to here? It goes up, come back down, come back up. So the left arm is down and the right arm is up. Now, if that had been a negative, it could be that would have been inverted then. So just by knowing the ends of the graph and where it crosses the x-axis helps me a lot in getting the picture. Now, in this next one, odd degree, that means the arms go in opposite directions, but it's a negative. So now instead of the left arm being down and the right arm being up, it's the other way around. The right arm will be up and the left arm will be down. So this graph would look something like this. So, here's what I want you to help me do right here. I want you to help me. See if you can see all of this first. Yes, okay. This is for right, yeah, okay. All right, pause the video now and copy this. Okay. All right, let's look at this first one. Let's first see what the degree is. So what I want to know is what's happening to the very left end of the graph. Is it going down or up? And the very right end of the graph. Is it going down or up? All right, so let's see what degree is this. Well, this is in factored form. So this is an x and an x and an x. So this is x, three of them, so that's x cubed. So that means odd degree. That means it's either left arm down, right arm up, or left arm up, right arm down. One of the two. All right, what number's in front? +1 times a +2 times a +3 is a positive. So it's an odd degree, positive leading number. Left arm will be down, right arm will be up. Left arm will be down, right arm will be up. Find my pen. Sorry about that. So in this one, left arm is down, right arm is up. Now this next one. This one this one's already multiplied out. I like this form better because you can look at the zeros. This is a fourth degree polynomial, negative. Even degree, negative front number, down, down. Now, got to be a little careful about this next one. Because you don't just say x, x, x. It's x2. That's another one, so that's x3. And then this is x3. So that's x3, x1, x2. So that's x6 all together because you add exponents. So this is a sixth degree polynomial. That means both arms go up or both arms go down. x2, One more is 3, 4, 5, 6. So this is even degree, positive, positive, positive. So it's positive even. That means both of these arms will go up. And then this next one is an odd degree. That means the arms go in opposite direction. It's a negative odd degree. So that means it's left arm up, right arm down. Okay. Now, what I want to do with you is I want to let's see how I want to do this. Okay, yeah, I think what I'm going to let you do is I'm going to let you copy this problem down, then I'll show you where the numbers come from. All right, we're fixing to do 2 more problems. We're going to do this one and one more after this one. Yeah, I think we can get this one in. So, all right, because you have one in the homework, you'll have one on the test like this. So write these instructions right here down. Graph the following polynomial. Now remember I told you a while ago, I said there's 2 things that we need to do in order to graph a polynomial. One is we need to know the zeros. And secondly, we need to know what the behavior is. That's not all, but those are the 2 things we need to know initially. Okay, so write this problem right here down. Graph the following polynomial. So here is the problem. And that's the way it will be worded in your homework and on test. It'll say graph, and that's all you'll see right there. Now here's what I'm about to do. I'm about to uncover it so you can pause the video and copy it all. After you copy it all, I'll let you sit back so you can watch me how I go through everything. All right, so give me just a second. Let me make sure I get all this in the window here. Make sure you can get it all. Okay, pause the video now and copy this. All right, so I'm assuming you've got it copied. Now let's go back up to right here. All right, the first thing that we do is let's talk about the degree of it. X, X, X. That's a 3rd degree. Now, is it a positive leading number or a negative leading number? Positive 1, positive 1, positive 1. So it's a positive odd degree. That means the left arm is going to go down and the right arm is going to go up. So remember that. The left arm is going to go down, the right arm is going to go up. All right. Now let's get the 3 zeros. Negative 3, negative 1, and positive 2. That's easy to do because this polynomial is in factored form. So the 3 zeros are negative 3, negative 1, and negative 2. Now, here's the problem. Don't draw this. I know that the graph crosses here. I know that it crosses here. And I know that it crosses here. I know that this left arm is down and this right arm is up. And I'm quite confident that in between here and here, it probably comes up and then it probably comes down like this. Here's the problem. In between negative 3 and -1, I don't know if it comes up that high or if it does this. And comes way down here. So the problem is, I don't know how high and how low it goes. So here's what I'm about to do. And this is why I draw this right here. All right, so I put my 3 zeros on a number line. Make a XY chart. And when you make a XY chart, I'm going to plug in a bunch of numbers for X. Here's the numbers I'm going to pick. Whatever your first 0 is, go one number to the left of it. So here's -3, it's a 0, go one to the left. So -4. Whatever this number right here is, go one more whole number to the right. So what I want to do is I want to let X be everything from -4 to +3. -4, -3, -2, -1, 0, 1, 2, and 3. That's why you see these numbers in this chart right here. Now, what I want to do is I want to find the Y values that goes with these. So here's what I did. So we're going to start with -4. And we're going to plug it in right here. So I rewrote it. All right, let X be -4. -4 plus 3 is -1. -4 plus 1 is -2. -4 minus 2 is -6. You're multiplying these three numbers. -3 times -1 is 3. 3 times -6 is -18. All right, now, plug in. There's -4, -3. Now, -3 is a 0, so I know what that number is going to be. Now plug in -2. All right, over here. -2 plus 3 is 1. -2 plus 1 is -1. -2 minus 2 is -4. If you multiply these three together, you get +4. Now plug in -1. Well, it's a 0. Now I'll do one more. Plug in 0 now. I'm going to plug in 0, 1, 2, and 3. Plug in 0. X is 0. 0 plus 3 is 3. 0 plus 1 is 1. 0 minus 2 is -2. 3 times 1 is 3. 3 times -2 is -6. Then plug in 1, you're going to get -8. Plug in 2, you're going to get 0. Plug in 3, and you're going to get 24. You plug in 3 up here and multiply those numbers out, you get 24. Then you take these ordered pairs and you plot them. Now, if you will notice, because these Y numbers get big, I used a scale of 5. 5, 10, 15, 20, -5, -10. So when I plot -4, -18, that's to the left 4. 1, 2, 3, 4. But when you go down, you're counting by 5s. 5, 10, 15 is right here, so 18 would be a little bit below it. And so you find your 3 zeros, start with the number on the left and go all the way across, plug those in to sketch your graph. Okay, in this next example, we're going to do one more example, and that will close out section 3.4. So this concludes 3.4 video part 1.